So the first unit that we encounter in physics are generally units and dimensions. Um, so what are units and what are dimensions? So anything that you can measure are something that we call quantities, right? So in specific sensitive physics, we call it physical quantities. So for example, if you have a box and if you want to weigh the mass of it, you are measuring the mass. So mass is a quantity. If you have a board or something and you want to measure the height or the length and the width of the board, what you're measuring is the length. If you have a beaker filled with water and if you're having it heated for a while and you want to know the temperature of this, you are measuring the temperature. So anything that you measure or that could be measurable is what you call a quantity. So you have tons of quantities. So these are only the very basic quantities. So you have mass, length, temperature. You could have velocity. You could have force. You could have time, current, and you can keep going, right? So mass, if you take anywhere in the North America, they measure it in pounds. If you go to Europe, they measure it in kilograms, and these are not the only mass units that you know of. If you are taking medicines, probably the medicines are measured in milligrams. If you are dealing with huge masses like containers and stuff, they are measured in tons. So there are different ways which you can measure these, right? So those are what we call the units. So why do we have units? So there are units because, for example, if you have a kitchen scale, right? So you have a kitchen scale which tells you everything in grams, right? So the maximum this kitchen weighing scale can measure is, let's say, 700 grams or 0.7 kilogram. Is it possible to measure the weight or the mass of a car or something, or maybe a container? Is it possible to measure the container's mass using this kitchen weighing scale? No. So we need a different scale to measure it. So that is one thing. So the second thing is maybe if you are going to use it for a medical purpose and you have a medicine or a capsule and you want to measure the mass of the capsule and you are about to consume 0.51 grams, or maybe you want to consume 0.5 grams. So this kitchen scale might show you 0.5 grams, but this 0.5 gram could have been 0.45 grams because using the approximation, we know that this 0.45 is approximated to 0.5 grams, or this also could have been 0.54 grams, which is also approximated back to 0.5 grams. So this is what we call significant figures, right? So for the time being, let's not worry about the significant figures, but understand why we have different units. Because using a single unit, we cannot measure everything that we have in our book. So it is the same thing. If I want to measure the length of a road, we measure it in kilometers. We don't use our foot ruler or we don't use our tape measure. But if we want to measure a piece of cloth, we use a tape measure, right? So tape measures are usually in meters or maybe in centimeters, but anything that you want to measure the road in, it is going to be in kilometers or maybe in miles if you are from North America, right? So different units are there for each and every quantities, right? So for temperature, let's say you have degree Celsius, you have degree Fahrenheit, you have Kelvin, velocity measured in meters per second. You can measure it in kilometers per hour, or you can measure it in centimeters per second, depending on the situation. Force, it is newtons generally. You can go for kilonewtons. You can go for, there is a unit, I've forgotten which is used to measure in North America. When I remember it, I will let you know. Time, seconds, minutes, days, years. current, amperes, milliamp, microamps. There are different units, right? So so in physics, in order to make things easier, we have 7 basic physical quantities, right? 7 basic physical quantities. So what are basic physical quantities? So using these 7 basic physical quantities, what you can do is you can measure literally anything, right? So what are those basic physical quantities? So we have mass, we have length, we have time, temperature, current, luminous intensity, and we have amount of substance. So as we go down, we will learn what these quantities and what do we measure using, because I believe the first 5 of them you might be familiar with, but the last 2 you may not know what they are, right? So we have the first thing, which is the unit, right? So if we are going to understand the unit of mass, specifically we will go with SI units. Mass is measured in kilogram, length is measured in meters, time is measured in seconds, temperature is capital K, Kelvin, current is capital amp, luminous intensity capital C, simple D, amount of substance mole, right? So this CD is we call candela, right? Amperes for A for amperes, and K for Kelvin. So you can notice that some of these units start with a capital letter, especially this one, and this one, right? So why do we have capital letters? So the reason why we have capital letters are because these are the names of the scientists who are related with these quantities. So Kelvin is the name of the scientist related with heat. Candela is the name of the scientist related to the light. Amperes is the scientist related with the name of the current. So that is the reason why we have those letters marked in capital letters, right? Others, everything starts off with small, especially this Newton. We know Isaac Newton, right? So Newton is related to force, right? So that is the reason why we have those starting off with capital letters. Then we have something that is that we have not or that we don't use in our day-to-day life, which is what we call dimension. So what is a dimension? So there is a whole chapter which is called dimensional analysis. We will get into that later on, but what are dimensions? So mass has a dimension which is capital M, length has it capital L, time we have it capital T, temperature we have it theta, current we have di, and for the luminous intensity and amount of substance we do not have a dimension. So why do we have a dimension in addition to the units? And we don't use dimensions quite often. So dimensions are something that we use in scientific studies to make sure that, to understand whether an equation makes sense, or maybe to find out how a quantity is related to another quantity and whatsoever, right? So that is what we call a dimension. So how exactly we can understand how exactly we can find out the units and the dimensions for other quantities is something that we will cover in a while, right? So if you have any questions, please let me know.